Hello, my name is Jelena Ponochko and I am representing the University of Manchester as the work package leader for CROSSBOW Regional Demand-Side Management Integration Platform, or DSM-IP. Together with my colleagues Petar Krstevski from the University of Cyril and Methodius and Lucas Pons from ETRA, we will present to you this product of the CROSSBOW project. What is DSM-IP? This is an DSM integration platform comprising algorithms, tools, and interfaces to enable coordinated cross-border demand-side management to facilitate optimal operation of the transmission network, for example, for voltage profiles managing or maintaining frequency profiles in the network. It also enables the cooperation between the TSOs and the DSOs. The Regional DSM integration platform acts as the enabler for coordinated DSM programs at a single TSO or multiple TSOs level. It facilitates cooperation, interaction, and data exchange between the TSOs and the DSOs. The main information exchanged will be the amount of flexibility from the accessible DSM assets, which can be single or aggregated controllable users at TSO or DSO level. The WAMAS, or Wide Area Monitoring and Awareness System, is a monitoring and control platform essential for network condition awareness and triggering events activating the use of DSM assets. Storage and DSM assets can be scheduled in combination based on the specific state in the network, as in some cases both types of flexibility sources will have to be activated. DSM-IP together with STOCC acts as a flexibility interface, enabling higher penetration of renewables in the system and at the same time representing DSM and storage as equal participants on the electricity market. Finally, wholesale and ancillary market will be one of the main enablers for cross-border DSM, providing novel market design for ancillary services and wholesale electricity market, aligned with the latest grid code and market developments to enhance the integration of renewables and DSM. With its advanced algorithms being developed, the DSM-IP will inform the TSO about the most suitable group of DSM assets whose demand should be either reduced or increased to facilitate satisfactory operating conditions in the network. This could be either voltage regulation or reduction of line congestion. Furthermore, the demonstration activities performed in 5 TSOs with DSM assets in this project will show the extent to which the existing DSM capacity could be used to solve operating issues in the regional power system. As an illustration of the output of the DSM-IP algorithms, here we can see a group of 5 DSM assets whose disconnection or load reduction will result in the high sensitivity of the line flow along this tie line in the south of the region. The sensitivity is calculated as the line flow after demand-side management minus line flow before DSM and divided by the size of the disconnected DSM asset. This means that with the disconnection of these 5 DSMs, we can regulate the transfer between the transmission networks in the south of the region. Similarly, for the tie line in the north of the region, these are the 5 DSM assets whose activation will result in the highest sensitivity of the line flow of this tie line.
The demand-side management integration platform can coordinate, optimize, and control a portfolio of DSM assets in order to provide bids for selling electricity to the day-ahead or intraday market. This slide shows the flows of power, data, and money for this business case. The electricity is sold in periods with high electricity prices, when the consumer's load will be reduced, and it will be shifted to periods with lower prices, thus gaining income. Additionally, the DSM integration platform can act to modify the load in order to provide frequency support services such as balancing capacity and energy, and participate in the balancing market as balancing service provider. The platform will monitor and control multiple DSM assets located in different countries. The market participation will provide steady revenue stream for the product that shall be distributed to the owners of DSM assets for their services. This slide shows the value network graph for the case when the demand-side management integration platform provides constraint management services. These services help grid operators such as TSOs and DSOs to optimize the grid operation for physical and market constraints. Constraint management takes various forms such as voltage control, grid capacity management, congestion management, and contribution to system stability. Also, the platform can provide services to the owners of RES generation at regional level. These services will contribute to increased RES penetration. With the coordinated demand-side management, the system load can be increased in periods of high RES generation in order to avoid or mitigate curtailments. In periods of low RES generation, the load can be decreased. The surplus of energy from RES generation that can be sold on the markets will be sold to the DSM assets, and the owners of RES generation will gain extra income by avoiding curtailment or imbalance payment.
DSM-IP features a graphical user interface that allows managing and monitoring the facility from the point of view of the facility owner. The tool allows managing a portfolio of facilities and provides different views in the real-time and aggregated electrical measurements that are useful for the facility owner to understand the electrical behavior of the facilities. The tool presents also the information in a map with a summary of the facility assets and the main electrical measurements. This is a feature that could be particularly useful when the portfolio grows up. The tool also allows to obtain detailed information of each facility and provides different visualizations for this data. The first tab provides measurements aggregated by month, the typical billing aggregation period. This is useful to compare among different months. The second tab depicts a calendar with the distribution of the demand by day and hour. This helps understanding the facility operational behavior from the point of view of the electrical consumption. Other useful information is the economical analysis. The electrical price and cost market related information is presented based on the tariff chosen by the facility and applying the actual energy prices. In case a multi-period tariff is chosen, the distribution of the energy consumed in the different periods is shown in the form of a pie chart. Finally, there's the possibility to plot any of the electrical measurements of the different facilities to monitor its evolution and compare with other assets. In this chart, the integration period is configurable as well as the set of measurements to plot. The available measurements depend on the sensor installed in the field and can comprise active power, aggregated exported and imported energy, current, voltage, frequency, power factor, and reactive power by quadrant. As it has been described, WAMAS is in charge of monitoring the power flows and measurements of the assets in the region and apply corrective actions upon the eventual identification of security problems. In this case, DSM-IP services are invoked by WAMAS for obtaining the sensitivity factors of the demand-side management assets in the region with respect to the identified problem. With these values, WAMAS identifies the minimal set of corrective actions to the DSM assets that solve the problem while are still feasible and economically efficient. These control commands are identified and sent to the DSM-IP graphical user interface. WAMAS operator can review these commands in the appropriate section. The control command information in the WAMAS tool include the affected asset, the active or reactive power set point, that in the case of DSM can be positive or negative, the reason for the command to be applied, the starting time, and information on the success or not in the command transmission to the DSM-IP graphical user interface. From the point of view of the facility operator, the system operator control commands are received and can be seen in the graphical user interface. The application warns operator on the reception of the command and presents the information in the appropriate section in the tool. The system operator limitation must be honored during the established period.
Thank you for watching this webinar. You can visit our website crossbowproject.eu to find out more information. Also visit our Twitter or YouTube channel.